us to do this question 1.2, which is from that revaluation question paper. It says, state all the steps involved in the design of a control system based on the analogy of an air conditioning system, right? So basically what happens is that you can do this as a design process, those steps, or you can do it as a block diagram as we see here, right? So for this purpose, what I've done is I've taken the block diagram of a standard closed loop control system, right? So this is from our textbook. So you can see that this is the control system here. You have the input, you have the input transducer, you have the controller, the actuating signal, disturbances, then the process and the plans, and then the output transducer, which goes back to the feedback loop, right? The summing junction here, right? So what we need to do here is now to realign this in the analogy of an air conditioning system. Okay, so this is where the question gets tricky. What happens is we now need to say how will this system look for a air conditioning system. Okay, air conditioning system. Okay, right. So how does it change? So all that you need to do is now need to use your ideas here. So let's start marking it out. We're going to use the exact same block diagram, but the thought process needs to come in. So what will be our input or reference in this case? It will be your desired temperature. That will be our input. What will be your transducer in this case? The transducer we've discussed is the device that takes the input to a form that is suitable to the machine. So in your case, or in our case here, we can see that we will be entering temperature, which is either digital or analog, whatever it is. But that needs to be converted into a voltage. So the transducer in this case will be the thermostat. Okay? So that is the transducer. So you see, this is where that inner knowledge comes in. It's no longer where you just copy a block diagram and put it on paper. You need to be able to use your senses for that. Now we'll come back to the error or actuating signal, but what will be our controllers first? So when we're having a air conditioner, there will be heating and cooling elements. They are called compressors, right? So that is what is going to control. So it's going to be your heating and cooling elements, and they are called your compressors. So it requires that you have an in-depth knowledge of every system. You need to know what a controller is and how do a controller work, and then how you're going to take that forward. Now the disturbances, you are quite open. You can actually say like an open door is a disturbance, right? Now we'll come to disturbance too. But then importantly, what is the process of the plant? So what drives these heating and cooling elements? Mostly in all processes, it will be a motor that runs it. In some cases, it will be different. You need to have a look at that. Because in some closed loop systems might not be electrical. They might be mechanical, right? Or they might be driven by some other kind of a device. Then it might not be a motor. So your thoughts need to be expressed there. Another disturbance might be a let us say, this we can even call it an open door, or we can even call it like any other factors. Like we can say that there's dust, dust in the AC vent, right? Dust in the AC vents. That is another form of disturbance. You can even put it as open door, open window. It doesn't matter as long as that concept is understood. Then out over here, the output of the control variable, it is the actual temperature that you get, right? That is the output. Now the output transducer and the input transducer, they're going to be the same, because I'll tell you why. I'm sure you guys know as well. Because when it comes to the actuating signal should be the difference between the desired and the actual, right? So it should come from the same kind of a device. So if the input temperature is 25 degrees Celsius and the output temperature is 22 degrees Celsius, then the error or actuating signal is 25 minus 22, which is 3 degrees Celsius. So your error or actuating signal is your desired temperature minus your actual temperature. So that's what is going to be your error or actuating signal. So this is how that question should be answered. So it should contain, you should remove all these components, and in its place you should be able to put these factors, that is your with reference to what we have here. So this is how it's going to be different. In our textbook, so this can be in many different forms. It can be a cruise control of a car, it can be a water boiling system, it can be any kind of. It can also be open loop. So you need to be able to suit yourself to that. An example of this is given here, where in our textbooks, where we see this in the form of the antenna positioning system. There we can see that. Let's have a look. Yeah. This is a good place to start. This is the antenna azimuth system. So if you have a functional block diagram, that will help you to create this a bit better. So whenever you get a question like this, you need to be able to draw the functional block diagram. You need to say, okay, what will be happening in the background for these things to happen? And then you can actually bring that forward. Let me just see if I can zoom this out. Yeah, here we go. So you can see that in this system, let's go to the original diagram in the textbook. There we go. The original diagram in the textbook. I'm looking for that question there. Yeah. You see that this first one here, they only have the potentiometer and the antenna. Now, when it comes to the second one, that's where they actually expand it out, and they actually give you an idea about how the system functions. So here you have the potentiometer, you have the differential amplifier, the motors, the gears are the ones that turn the stuff. So what is the idea here? You want to turn a knob, which is this knob here, right? You want to turn this knob, and you want to turn the antenna. So here, turning the antenna is what we need to do, right? So for you to turn the antenna, you know that you need gears and like power amplifiers and things like that. So firstly, the potentiometer is the one that you're going to use to change the direction. Then you're going to amplify that. The motor is the one that is going to drive the gears, and it's going to turn the antenna. So that is what you see here. Angular input, potentiometer, then the actuating signal, the control of the process, and then again back to the potentiometer. So you need to, whenever a question is asked, you need to be able to create this kind of a functional block diagram and take it back into the control system's closed loop or open loop system block diagram view. So this is how you tackle a problem of this nature. So just by having a knowledge about the basic control system block diagrams will not help. You need to be able to try and see what will happen behind. So this is how that question is answered.